I just remembered. I can use the headphones. Route the mixer through the headphones. And also route it to the stream. And then we won't get any feedback. Let's have to implement some solution for this. But right now, we're not getting any more feedback. Yeah, can you hear that? The type of noise is higher pitched when it goes to the upper filter, which is the nothing filter. So listen, this is high pitch. And this will be lower pitched. Ah, shit. And this will be lower pitched. Anyway. Okay, so that works as we might expect. The sounds now go a lot faster. Now we want to do something more sparkly with the effect. So, again, I picked sparkle because the word sparkle because sometimes delay and I've heard maybe people do like an elf voice. Besides the pitch shift up they might do, they okay, for example with Protoss in StarCraft, if you play that game, StarCraft 2, the Protoss will always have delay in the voice. And I've noticed this in a few like spacey, sparkly races in gaming universes. And yeah, it's generally implemented by having the original speaking buffer and taking copies and shifting them around. You can do little things like just reverse a segment and just do a quick reverse and unreverse. And that essentially brings you back and forth to the same point, right? If you play backwards and forward and continue. So that will like lengthen the sound and make it a little like add that, you know, that weird backwards tape feeling when you play a tape backwards. I hope that's not like a generation gap thing. When I listened to Michael Jackson, it was on a tape, a cassette tape. Anyway. Let's start doing some delay stuff, and then we'll figure out the sparkle from there. So what we will need for delay is an extra buffer, because this process sound internal call, as you can see, there's only one buffer that we have. So the next buffer comes in out of scope. I mean, we don't, it's not what I wanted to say. Let me shrink the camera time and stall a little bit more by drinking water so I can form one coherent sentence. And the pressure's on. Alright. Sparkle effect needs a delay buffer because we only have one buffer at hand, and we're going to want to use this buffer in the next call to play sound internal, so we need to save it. Luckily these buffers are do we want to do it like this? Luckily these buffers are referenced. So we don't have to make a copy, we can just add a reference and keep a pointer, and that'll be good enough. If we do that, we have to keep a cursor within the pointer to figure out where we want to play back from. And keep in mind that these are small buffers. Right now there are 1024 samples, which is on the larger side of a audio callback, but we could shrink it down to 256 probably, or at least 512. So we want to do something that's independent of the size, but we will need more than one of these buffers if we want to do anything perceptually useful for delay. With a small delay you can do still cool stuff like flanger and these filters, but you cannot do the things maybe because of guitar pedals and such, the things we think of when we hear the word delay, like an echo. That's a long amount of time compared to these 1024 samples or 512 samples. So I think we need a vector. The other option is to have a ring buffer, and that's probably a more common one. A more common solution. So let me think, would I want to do that? I don't have a ring buffer class yet. We will have to define one at some point. A ring buffer class means a little bit of extra memory, but this is almost negligible. Well, I'm in hack and slash mode right now, so I just want to get it out. I'm going to use a vector, because we've been using so many things of this form already. So there's a struct called filter buffer, and this is what we get as input. And I'm just going to take the pointers of this, and this is going to be called our delay buff. And we need two pointers, two variables to keep track of where we're at. One is the, I'm just going to use the size t to do this. So it's going to be m delay buff. And this is going to be m delay sample. Is that right? It's not the best, well, whatever. I guess this class will just have all its member variables have the name, the word delay in it. Or at least this refers to delay. This is reasonable. Okay. So, the first thing we'll do is just add a straight echo. Because that's a very obvious sound. And we can modify that later to do something else. But for now, I'm just going to put it in a defined echo delay. And we'll just say this is in seconds. And I like to write the unit at the end. Echo delay seconds. So what's a good echo? Hey, 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 hey. That's too fast. Hey, 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 hey. Hey, hey, hey. Let's put it at 0.5 seconds. That's a reasonable delay, and it means we have to span several buffers. So to do that, ooh, you know what? Yeah, okay. To do clear state on process sound. Okay. I'm going to do that right now. So we're going to override process sound just a little bit. because we're going to do the same thing. I'm wondering if there should be a reset call in process sound, or if that should just, I mean like a reset state. I think there should be a reset state, don't you? Yeah. And we'll just add that to effect entities process sound. Yeah, so right here. Is it right here? Yeah, it is right here. No, this is where we're releasing buffers, so this is where we'll do it. Clean the state for this sound. Okay, so we want to do self reset state. Yeah. And it looks like we're already doing some of that with this output buffer stuff. But this reset state can be for the subclasses. So let me add that to the class definition of effect entity. Sent to subclasses. Well, reset the state for the next call to process sound. Next sound to be processed. Subclasses should override if they have state. Yeah. Okay, so we're resetting the state, and that means we pretty much take our delay buffers size ti equals 0, I less than m delay buff. Why don't I use caps for that? And delay buff I plus plus. Right? Then when we're resetting the state, we have to decrement that reference count. That's going to be ref count. Minus. And we also should, at this point, kill. Yeah, we should kill. What do we want to do? You know what? I got it. Yeah. So the question is, if we want to have our own buffers, if we want to manage our own buffers or just steal the